Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Ezzat Aziz bin Ellah Aziz. My Maitri ID is 202456E291. On this grateful day, I want to presenting one of article that I have been reviewed, that is Building Information Modeling and Internet of Things Integration for Facility Management. For the introduction of the topic and authors, the article Building Information Modeling and Internet of Things Integration for Facility Management, Literature Review and Visionaries, authored by Antonino Manino, Mario Claudio Di Ciacco, and Fulfiori Cicconi, provide in-depth explorations of the integration of Building Information Modeling (BIM) and the Internet of Things (IoT) for the Facility Management (FM). The author are affiliated with the Department of Architecture, Built Environment, and Construction Engineering at Politecnico di Milano, published in Applied Science in 2021. The paper underscores the critical role of digitization in the architecture, engineering, construction, and operations (AECO) sector, particularly in optimizing facilities management process through advanced technologies like BIM and IoT. For the content summary, the article explores how integrating building information modeling with the Internet of Things can improve facility management practices. The authors begins by contextualizing the topic within the broader Industry 4.0 revolution, highlighting the construction sector's slow adoption of digital technologies compared to other industries. They stress that facilities management account for a significant portion of a building lifecycle cost, up to 85%. Yet remains under-researched and underutilized in terms of digital innovation. The article's primary focus is on bridging the gap between BIM and IoT, emphasizing their complementary potential. BIM offers a digital representation of a facility's physical and functional attributes, while IoT collects real-time data from sensors to monitor and manage various aspects of a building's performance. Next is the significant benefit of these technologies. Firstly is enhanced data management, consolidating data from design, construction, and operational phases to reduce fragmentation. Second is risk mitigation, enhancing safety and emergency response capabilities by integrating IoT sensors with BIM models for real-time monitoring and simulations of scenarios like fires or structural failures. Third is predictive maintenance, using real-time IoT data integrated with BIM models to forecast potential system failures and optimize maintenance schedules. Last one is improve operational efficiency, streamlining the process and enabling data-driven decisions to reduce costs and improve sustainability. Besides, the paper also systematically reviewed 99 selected journal articles from Scopus and Web of Science, focusing on BIM IoT integration within facilities management. It identifies key research themes such as sustainability, risk management, and operations, while also highlighting areas requiring further explorations. So the authors propose a future research agenda, which includes: first, standardizing data formats to improve interoperability between BIM and IoT systems. Second is exploring the role of technologies like artificial intelligence (AI), augmented reality (AR), and virtual reality (VR) in enhancing BIM IoT integration. And the third one is developing framework to integrate real-time IoT data into BIM for continuous update during the facility life cycle. And the last one, addressing organizational and cultural barriers that slow down the adoptions of these technologies. For the critique of the issues discussed, lack of practical applications, the paper lands heavily on the theoretical discussions and volumetric analysis without providing empirical case studies or real-world examples to validate the proposed benefits. For instance, while predictive maintenance and risk mitigation are highlighted as key advantages, there are no concrete examples demonstrating their successful implementation. Second is challenges identified but not addressed. The article discussed challenges such as fragmented data systems, limited interoperability, and resistance from stakeholders, but does not provide actionable strategies to overcome these issues. For instance, while it acknowledges the need for standardizations in data formats, it does not propose any specific pathways to achieve this. Third is over-reliance on secondary data. The insights are derived from existing literature which limit the originality and depth of the analysis. While this approach provides a broad understanding, it does not offer a fresh empirical insight or innovative solutions to the challenges discussed. Fourth is focus on sustainability is limited. Despite sustainability being highlighted as a critical area, the discussion is primarily centered on energy management, overlooking other important aspects like water conversion, waste management, and material efficiency in facilities management. Last one is technological readiness not fully explored. The article does not delve deeply into the technological readiness or cost implications of implementing BIM IoT integration on a large scale. For example, the practical difficulties on integration IoT sensors with existing BIM models or the financial feasibility of developing such systems across different types of buildings are not truly examined. For the critique summary, while the article effectively outlines the theoretical benefits and challenges of BIM IoT integrations, its lack of empirical evidence, limited focus on practical implementation, and failure to propose actionable solutions reduce its overall impact. However, it provides a valuable starting point for further research and serves as useful resources for understanding the current state of BIM IoT integration in facilities management. From my point of view on the impact of the article discussion for project management practice, it consists of 4 positive impacts. First one is data-driven decision. IoT sensor integrated with BIM enable real-time monitoring and predictive analytics, allowing project managers to prevent risk and optimize performance. Second one is operational efficiency by leveraging IoT data. Project managers can implement predictive maintenance, reducing downtime and cost. Third is improved collaborations. BIM serves as a unified platform for stakeholders, reducing communication gaps and ensuring everyone accesses the most current data. The last one is life cycle management, integrating facilities management consideration during design and construction shift project management toward a proactive, life cycle focused approach. Challenges to adoption. The first one is interoperability. The lack of standardized frameworks for data exchange between BIM and IoT systems can hinder implementation. Second is resistance to change. Cultural reluctance within organizations may slow adoption, requiring training and advocacy from project managers. Third is high initial costs. Upfront investments in hardware, software, and skilled personnel may deter smaller firms despite a long-term benefits. Last one is data security. Ensuring the privacy and security of sensitive IoT generated data remains a critical challenge. For the conclusion, critical evaluation, the strengths of the article lie in its detailed bibliometric analysis and its systematic identifications of research gaps. By reviewing 99 key studies, the authors demonstrate the growing academic interest in BIM IoT integration and its application to facilities management. The discussions around sustainability, interoperability, and predictive maintenance is especially relevant as these are pressing challenges for the AECO sector. However, the article is primarily theoretical with limited real-world examples or case studies to validate its findings, while its outline potential solution is stopped short of providing actionable strategies for addressing the identified challenges such as resistance to digital adoption, high implementation costs, and data security concerns. Additionally, the discussions on sustainability could have been expanded to include aspects like water management and waste reduction, which are integral to holistic facilities management. In my point of view, the article addresses a highly relevant topic that reflects the ongoing transformations in the construction and facility management industries. BIM and IoT integration has the potential to revolutionize the project delivery and building operations by enabling real-time monitoring, enhancing data-driven decisions, and optimizing life cycle costs. However, its practical adoption requires overcoming significant hurdles, including the standardizations of data formats, interoperability issues, and the cultural inertia of stakeholders who may be resistant to change. The emphasis on Industry 4.0 technologies like artificial intelligence (AI) and augmented reality (AR) open existing possibilities for future research and application. For instance, combining IoT data with AI could enable even more sophisticated predictive analytics, with AR tools could make facility data more accessible to on-site managers and operators. To maximize the benefits, it is essential to foster collaboration among industry stakeholders, provide training on these technologies, and develop policies to standardize their implementation. Final thoughts on the topic: the integrations of BIM and IoT represent a critical step forward in digitizing the constructions and facilities management sectors. Is aligned with broader global trends towards sustainability, efficiency, and innovations. However, its success depends on bridging the gap between research and practice. Future studies should focus on empirical case studies, cost-benefit analysis, and strategies for overcoming real-world challenges to adoption. As the AECO sector continues to embrace a digital transformations, BIM and IoT integration will likely become a cornerstone of modern facilities management practices. The insights from this article serve as an essential foundation for researchers and practitioners aiming to harness the full potential of these technologies to improve building performance and user satisfaction.